Hello, thank you for checking out A1 Math, and today we're looking at modeling exponential growth and decay. So let's begin. Okay, so in a previous video we talked about modeling exponential growth and decay. We talked about the two formulas that come with it. Y is equal to A times 1 plus R raised to T, and Y is equal to A times 1 minus R raised to the T for decay. So what I want to do is show you how to take a word problem and interpret it, um, write the function, uh, and graph it, and describe what's going on with the graph. So let's take a look at an example. Okay, here it says a baseball trading card is sold for $2, and its value increases by 8% each year after it is sold. It says find the value of the baseball trading card in 10 years. Now, the first part is we want to write the exponential function. So that's what we're going to do. We're going to plug in everything we have. RA, which is where it begins, is 2. And we're going to take our percent, which is 8%, and convert it to a decimal by moving, convert it to a decimal by moving it two places to the left. So that's going to be 0.08. So now I'm going to plug that in, 0.08. Now I can add the 1 plus 0.08, but in the previous video I told you could just type in the calculator from here, which you can, but we're just going to add it right now, and we will get 1.08. All right, so the next thing they want us to do is find the value in 10 years. So we're going to write the function, which is 2 uh, times 1.08. That's exactly what I got from right here. But now we're going to plug it in with the number of years we need to know, which is 10. So we plug that in. Okay, so once you do that, you'll end up and type in your calculator here. Let me show that again. You round it to a whole number, not a whole number, but a um, money amount here. You got 4.32, so it's $4.32. All right, so after 10 years, the baseball trading card is worth approximately $4.32. All right, so now what we want to do is we want to graph it. Okay, now this is one of the most important parts here. Um, this is kind of done for you, but uh, in the next problem, you may not have that. So keep in mind to plug in your X value or your T for the time for the baseball cards, we want to do whatever they give you in the graph. So they give you 0, 3, 6, 9, and 12. So we're going to use 0, 3, 6, 9, and 12. And we're going to plug those values into the calculator. All right. So off the top, if you plug in 0, you know you're going to get A, which is in this case 2. So write that red. All right, let's do the next one here. We plug it in. I will tab back. Instead of having 10, I am going to put 3. All right, and I get 2.52 if I round up here. So 2.52, rounding to the nearest hundred. And if you keep doing that, you'll end up with 3.17, 4, and 502. Okay, and this part's not necessary, but you could tell that these are the points here, 0, comma 2, and so on. So now you're just going to graph those. So you go over to 0 and go up to 2, which is about here. And it's kind of hard to graph, but you can see that this will be in between 1.5 will be in between, and well, 2 will be in between 1.5 and 3 here. All right, you come over to 3 and go up to 2.52, and that'll be just about here. Then go over to 6, and 6 is going to be 4, just about in here. And then go over the, oh, 6 is not 4. 6 is 3.17. 9 is 4. That's going to be a little closer up here, right in here. And 12 is 504. Right, look this up the lane, right in here. So this is getting our exponential function here. All right, so the next thing we're going to do is we want to determine a few different things. We want to know what the domain is, what the range is, what the asymptote is, and um, what the y-intercept is the value of the y as t equals 0. So we just want to know what y-intercept is, what it means in context, okay? So let's start. So the domain is all your x values, okay? And we want to determine it not in the actual sense, but in, well, as far as the graph that goes on forever, we want to determine in the words of the problem, okay? So for instance, we start here with 0, and the 0 is representing the time, okay? And over here on the y-axis, this is how much money that happens here. So that's money, right? So at 0, when you first get it, it's $2. Okay, so you're not going to have a negative time. Okay, that'll bring this down. So it's going to be such that t is greater or equal to 0. Okay, now it keeps on increasing in value. It's going to keep going up. Okay, so since it keeps going up, we know that the y is going on for forever. But as far as the range is concerned, how low does it go? How far down is it going to go? Well, since it's not going past 0, as far as down as it's going to go is 2. Okay. Next, we're going to do the asymptote. Now, if this did keep going, it'll keep going, keep going. Since it hasn't been shifted or anything, the asymptote is going to keep going and end up being 0. Okay. So as we do the asymptote, we're not talking about in terms of the word problem. We're just strictly talking about what line does it get closer and closer to. Okay. So it's going to keep getting closer and closer to 0. So on here, we're going to put the asymptote is such that y is equal to 0. And then finally, what does the y-intercept mean in terms of the problem? Well, it means the initial value where the card was sold. So it's the value of the card when it was sold. Okay, so that's a lot of steps there. But what we want to do is go back to the beginning here. Is first write out the function, answer the first question, what happens at 10 years. Take the numbers from the graph and use that for our x. Plug those in and then graph the function and then tell what the domain, range, asymptote, and what the y-intercept means in terms of the problem. Okay, let's take a look at decay. All right, so the next one here is decay, exponential decay, and it's got that same formula we talked about in the previous video, with y is equal to a times 1 minus r raised to the t. Okay, so remember, we have to interpret the word problem and see if it's going to be growth or decay. Okay, so let's take a look at an example. Okay, so in this example, it says the value of a car is depreciating at a rate at 5% per year in 2010. The car was worth 32,000. Find the value of the car in 2013. So they want to know what's the value of the car 3 years later. Okay, so right now it says write the exponential decay function for the situation. So we're going to start off with our A and R for our rate. So the A is where we begin. We begin with 32,000. All right, now we're going to plug in the rate. And the rate is 5%, but we're going to convert it to a decimal, make it 0.05. All right, so when we take the 1 minus 0.05, that's going to get us 0.95 here. And we'll bring down to 32,000. So this is our function. Our R, or better known as B, is less than or between 0 and 1. So you know it's going to decay. It's going to go down. Okay, so now I'm going to rewrite the function again. The same thing's going here. And I'm going to say 32,000 times 0.95 raised to the t. So now we're going to write it out, and we're going to plug in the value we're looking for, which is 3 years. So we got 0.95, and we're going to raise it to 3. Now if we take that and type into the calculator, clear this out, and say 32,000 times parentheses 0.95, close parentheses, and then raise it to the third. Okay, so the car value will be 27,436 in 3 years. Oh, and that's the same number here, 27,436. All right, so now we're going to go ahead and make the graph. It's the same thing we did before. And remember, we're going to get the numbers from the graph. They give us 0, 1, 2, 3, and 4, so that's what we're going to use here. 0, 1, 2, 3, and I guess we stop at 3 because that's all they gave us. Okay, so now we're going to plug those in. Now, 0 is easy because we could just use the function and realize that when we first started off here, it's going to be 32,000. That's when we first bought the car. Okay, and then you plug in 1, and you type that in the calculator. Give an example of that one. Okay, this will get us down to 30,400. And you just keep going. 2 would be 28,880. And then 3 would be 27,346. All right, let's see if this was a little bit easier to graph here. We're estimating again. We know at 0 it's going to start at 32. Okay, after 1 year, it's going to be 30,004, which is just down a little bit, about right here. And then 2 is going to be up a little bit more here. And then 3 is going to be just below this line here. And it doesn't have much of a curve, but it's still an exponential function. Okay, so now we've got our graph, and what we want to do is answer these questions. And this one is not asking about the asymptote, but we're just going to do the domain and the range, and then determine what the y-intercept means in context. So the domain is a set of all real numbers such that t is greater than 0. So you start off at 0, and it keeps going as far as you can. You know, like when the car depreciates all the way down to it's not worth anymore, it's worth 0. The years will still keep going, so the x doesn't stop. So the t is the domain is such that t is greater than 0, greater than or equal to 0. Now the y, that's a different story. It's not going to be worth more than 32,000. So y would have to be less than 32,000 or equal to it. And what's the lowest amount that the y could be? Well, it can't be negative y. The lowest amount that the car is going to be worth is going to be 0. Okay. Now, what does the initial amount mean? What does the y-intercept mean in context? In context, what that means is that when you first bought it in year 0, when you first bought the car, the value of the car was 32,000. So that's the original amount of the car. Okay. And that's an example of depreciation. All right, take a look at these two examples. You want to set up your own T-chart, and don't forget to use 0, 2, 4, and 6, and 8 for your x values to plug in. And you want to write out your exponential function, find out the question it's asking. The first one here is 8 years, and then make the graph, and then tell me what the domain and range is and what the y-intercept means in context. All right, here's number 10, okay? So we know we got our function, y is equal to a times 1 plus r raised to the t. It's an exponential growth function and wants us to state the domain, the range, and what the y-intercept represents. Sarah sold a coin for $3 and its value increased by 2% each year after it was sold. So now what you want to do is go ahead and write the function, which we did, plugged it in, we've got it, and then we've got 8 is the number of years. They want to know what the value of the coin is in 8 years. So that's how you get this. Okay. So next you want to set up a T-chart and plug in these values, 0, 2, 4, 6, and 8. And you can plot out the value of what the coin is going to be. The domains are set that all real numbers are greater than 0. And then the range going up is so that all real numbers is greater than 3. So everything greater than 3 going up. T is going this way. All right. Now the y-intercept means what does it means the initial value of the coin when it was sold. When she first bought it, it was $3. So at zero is $3, and that's what the y-intercept represents. All right. Here's number 13. Okay, it says the value of a boat is depreciating at a rate of 9% per year. In 2006, the boat is worth 17,800. Find the worth of the boat in 2013. Write an exponential decay function for this situation. Graph the function, state the domain and range, and what does the y represent in context of the problem. Okay, so first of all, you want to write the function. You begin with 17,800. We're going at 9% per year, but this is depreciating. So since it's depreciating, it's decay. So since it's decay, what we're going to do is subtract that rate. So we change it to 0.09 and subtract it from 1, and you get 0.91. Then we're going to plug in the number of years. So how many years is it between 2006 and 2013? Well, it's 7 years. So that's why we plug in 7 and get uh, that term here of how much the boat is going to be worth. Then we plug in 0, 2, 4, and 6, and 8, and we get these numbers here. And then we plot that out. We can see the drop of how the boat is depreciating. Okay. So as far as the domain, it's going from the year you bought it until forever. It just keeps going. So t is greater than or equal to 0. As far as the range is concerned, the highest it's going to go is 17,800. And the lowest it's going to go is 0. It's eventually going to get to 0 or nothing. Okay. And as far as the y-intercept in terms of context is so the 17,800 is how much the boat was worth when it was first purchased. So that's the value of the boat at the original value, and that's a decay. So to recap, that is exponential growth and decay, modeling it, graphing it, and describing what's going on with the graph. I want to thank you for checking out A1 Math. Have a nice day.